So for question 7, the question asks for the expected number of deceased subjects who are exposed under the null hypothesis of the dependence. So if you look at the table, we have the group, that's the group, then the deceased, then we have healthy, then we have the total, and we have the exposed, then unexposed, and total down here again. So for this one we have 9, 21, 30, as you can see. Then we have 11, 59, then 70. Then for the total, if you add, this is 20, this is 80, this is 100. So we want the expected count of exposed and deceased. So the formula for the expected count, so for the expected count is going to be total row, the row total, and remember rows are these ones, then the columns are these ones. Row totals times the column total over the grand total. So the grand total is basically grand total. I don't know whether that makes sense. So the row total, for the expected count, the row total is 30. So this is the expected. So for the expected, we are going to have the row total, and for this case, it's basically 30 times the column total. For the first deceased, we are having 20. So this is basically the exposed and the deceased, and that's the first thing. So 20 over the grand total, and our grand total is now 100, this part. So if you solve that, this 0 goes with this 0, this one goes with this one, then we are having 3 times 2, which is 6. So the most correct answer is C, and C equals 30 times 20 over 100. That's basically the most. So in other words, you just multiply the total number of exposed people by the total number of deceased people, then divide by the overall total. So that is the expected number, which is 6. So 6 exposed deceased subject in this case. 6 exposed deceased. Unaweza stopisha.